Hello everyone, myself Vinay Kumaram. I am pursuing PhD in physics. So in this particular YouTube channel, I will be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel. So in my previous videos, I was actually explaining the 9th chapter of 9th standard science subject that was on gravitation. So I have covered most of the topics which were there in this particular gravitation chapter. So in this particular video, the remaining topics which were there, which were left out in this particular chapter, I will be covering. So in this chapter, let us discuss example 9.4 and 9.5. So coming to example 9.4, here they have given mass of an object that is equal to 10 kg. Now you have to find out weight on Earth's surface. So now you have to find out weight on Earth's surface of this particular object. So what can be the weight on Earth's surface? So on Earth's surface, we all know that acceleration due to gravity is 9.8 meter per second square. So weight is equal to mass times acceleration due to gravity mg. So mass is 10 kg into acceleration due to gravity is 9.8 meter per second square. So when you do 10 into 9.8, it is 98 and SI unit of weight is Newton. So 98 Newton is the weight of this particular object on Earth's surface. So now coming to example 9.5. So in example 9.5, they have given an object and this particular object's weight is equal to 10 Newton on Earth's surface. So this weight is on Earth's surface, so that's why I'm taking WE. So that is weight on Earth's surface. So weight on Earth's surface of this particular object is equal to 10 Newton. Now you have to calculate what is the weight of the same object on Moon's surface. We studied that weight on Moon's surface reduces by 6 times compared to the weight of the same object on Earth's surface. So that is 1 by 6 of WE. So when you do 1 by 6 of WE, that is 1/6 of the weight on Earth's surface is the weight on Moon's surface. So whenever any object which you are taking on Moon's surface, that will lose weight by 6 times. So that's why 1 by 6 into WE is 10 Newton. So 1 by 6 into 10 Newton is there. You will get 1.666 Newton. This 6 goes on. So you can just round off this to 1.67 Newton. So this much amount of weight that particular object will be having on Moon's surface, and on Earth's surface it will be having 10 Newton. Remember, mass of this object is constant throughout the universe. So even on Earth's surface, on Moon's surface, wherever that object goes, mass of that object remains constant. But weight varies. On Earth's surface, the object is weighing 10 Newton. The same object on Moon's surface, it will be weighing 1.67 Newton. So now let us try to understand what do you mean by thrust and what do you mean by pressure. So here you have one topic in this particular gravitation chapter, that is thrust and pressure. So in our previous chapters, we have learnt about force. So any force which is acting perpendicular to any of the surface, then that can be known as thrust. So this particular symbol is for perpendicular. So this symbol represents perpendicular. So whenever a particular force is perpendicularly acting on a surface, so any force perpendicularly acting on any surface, this can be known as thrust. So now you might have seen certain examples around you. So for example, in one particular case, in your schools and all, if you have a notice board like this, I am giving the side view of notice board. Okay. So in this notice board, if you want to stick a pamphlet like this, then you will take a particular nail. By using this particular nail, you will stick this particular pamphlet onto this notice board like this. So now, while doing this, you have a notice board like this and you have a nail like this. So now, when you keep this nail on this particular notice board like this, you will put some amount of force on the head of that particular nail. So when you put that force in this direction, which is perpendicular to this particular notice board, that means you are applying thrust on that particular notice board. So here the force which is acting perpendicularly onto this notice board, here thrust is created. So thrust is a component of force which acts perpendicularly to a surface. So always remember, every thrust is because of force. So you can call thrust as force, but not always you can call force as thrust. You cannot call force as thrust. So you should remember this. So every thrust is a force which is acting perpendicularly to on a surface, but every force cannot be a thrust. So this one thing you can remember. So that means here you are applying force in one particular perpendicular direction on a surface. Then that kind of force can be known as thrust. And when that particular force come into existence, then pressure will be there. So always remember, the formula for pressure is thrust divided by area. So why we are considering thrust divided by area? Because how much amount of force you are applying on a particular area defines how much pressure you are applying. So for example, on the same notice board, if you keep nail in the opposite direction like this. So for example, if you just turn that particular nail and you are facing this nail head towards the notice board, and then if you are trying to push this nail inside notice board. So for example, nail's head is there like this and its sharp edge is in this way. So from here if you apply force, the nail will not go inside the notice board, because here you can see the head of nail is this much big, and that means here surface area or simply area has increased. So here surface area, or simply you can call the area as increased. Whereas this particular tip, if you are observing, it is just a sharp tip like this. So if this is a nail, then you have a sharp tip for this particular nail. So that sharp tip means there is less surface area. So when there is less surface area, same amount of force is enough to put that nail into the notice board. So now if you have notice board like this, so I'm taking two different notice boards. On one notice board you are putting nail in this fashion, and on another notice board you are putting nail in this fashion. So here you can clearly see surface area is more, and here you can clearly see surface area is less, because this tip only this much surface area is there. But whereas on the head of nail you have this much big surface area. So that means here, because this head of nail is having this much amount of surface area, how much ever force F you are applying, this cannot penetrate the notice board. But whereas this with the same amount of force can easily penetrate. So if you are putting same amount of force F in the both the cases, here nail can easily penetrate the notice board, but here nail cannot penetrate the notice board because surface area is more in this first case. So that's why here in this particular formula, pressure is inversely proportional to area. You can clearly see here pressure is equal to, thrust is nothing but force, so that's why I'm writing just force by area. So simply you can remember force by area. Always remember thrust by area is pressure. So here this force is thrust, and thrust by area gives you pressure. In this particular formula, area is in the denominator. So whenever the value of denominator reduces, the total value increases. So that means this particular pressure increases. Whenever this denominator value increases, then the total value decreases. That means this particular pressure decreases. So that means here, whenever area is less, pressure will be more. Whenever area is more, pressure will be less. So that's why head of the nail has more surface area. Hence, if you put same amount of force, pressure is not that much. But whereas if you in the second case, the tip of the nail had less area, because the tip of nail had less area, the same amount of force gave more pressure. So that's why that particular nail could easily penetrate the notice board. So now we can consider one more example. Let's say there is a loose sand in a particular place. So let's consider this as one particular place, and in this place you have lot of loose sand like this. So on this particular loose sand, if a particular person stands on his feet like this, then this person will be sunk inside this particular sand. If the same person sleeps on this sand like this, so let's say a person is lying on this sand like this, so at that time the sinkage is less. Here the person will sink more, and here the same person who is lying on his back like this will sink less. So here sinking will be more, so here sinking is more, but here sinking is less. So here sinking is less. Why this is happening? Because a person who is standing on this particular loose sand, so this is a loose sand, so a person who is standing on this particular loose sand has certain mass. So this person has certain mass m, and there is a gravitational pull downwards. So when there is gravitational pull downwards, that is acceleration due to gravity is there. Because of this gravitational force, acceleration due to gravity comes into picture. Because of that, this particular person will have weight applied on this particular sand. So that means this person will be having weight W, which is applied on this sand. So what is weight? Weight is nothing but force. Here weight is nothing but force due to gravitational force of Earth. So because force is coming into the picture, now you should consider here the area. You can see a person who is standing on this particular loose stand has a feet, and how much ever area of his feet is there, so that much amount of area, on that much amount of area this particular force is applied. Now if the same person is sleeping on the sand like this, is lying on this particular sand like this, then his entire contact what is there between the body and the sand will be considered as the total surface area. So here you can see the surface area of feet is less compared to the surface area of entire backside of his body. So that means here area is more and here area is less. So here area is less and here area is more. In both the cases, when man is standing and when the same man is lying on the sand, the weight will be same because his mass is same and acceleration due to gravity is same. So weight is same, but the contact area is increased when that particular person is lying down. Directly this particular weight is perpendicularly acting on this particular surface. So here weight of the person, so here weight of the person, so weight is W. So weight of the person is perpendicularly acting. So here perpendicularly acting on the surface of this loose sand. So that means when a force is perpendicularly acting on a surface, then thrust comes into picture. So now because the area when a person is lying on the sand, because the area of that particular contact between person and the sand has increased, the pressure will decrease. But when the same person, when he stands on that particular loose sand, at that time area of contact between person and sand becomes less and force remains the same. That is, the weight remains the same. Because weight remains the same and area of contact is less, pressure will be more. So in first case, when man is standing, so here in the first case, when man is standing like this on the sand, loose sand like this, area of contact between person and sand, so here area of contact is less. Because area of contact is less, pressure will be more. So pressure will be more. That's why sinking will be more. So because here pressure is more, sinking will be more. Similarly, in the second case, when the same person with same weight, when he is lying on the sand like this, so the force is same, that is the weight is same. So here also area of contact is same. Here weight is constant. Always remember weight is constant in this both cases. So weight is constant, but area of contact is less. But here, area of contact is more. So here area of contact, that is his entire backside of his body is in contact with sand with same amount of weight. So area of contact is more, hence pressure will be less and sinking will be less. So in second case sinking will be less. So in the first case area of contact is less, weight is constant, pressure will be more because area is less and sinking will be more. In second case with same weight, area of contact is increased, area of contact has increased, hence pressure will be decreased and sinking will be decreased accordingly. So now we can consider one more example where a particular engineer who is constructing building, he will take foundation for a larger area like this. So let's say a big building is built on a particular land, then larger area on this particular land is covered for this particular foundation. So foundation of a building covers larger area. Foundation of building always covers larger area so that the pressure of that particular building onto that foundation is reduced, because here the amount of weight which that building is carrying, so this building will also have certain mass. If it has mass means it will be having weight because of acceleration due to gravity coming into the picture. So there is a weight for this particular building, and if this particular foundation has larger area, then pressure on this foundation will be less. So pressure on foundation is less because the foundation has larger area. So weight of the building is there. So to maintain that particular weight of building, we have to put larger area foundation so that pressure will be reduced. So amount of pressure received by this foundation will be lesser because there is larger area for this particular foundation. So if you consider this as knife like this knife will be having sharp edge. This particular knife will be having sharp edge. That means here they have reduced the surface area of knife so that it can easily penetrate. When you are cutting vegetables or fruits, it can easily cut that vegetables or fruit because with less amount of force, more pressure can be generated because surface area is less. Because pressure depends directly on force and inversely on area. So that's why when area is less, then with less amount of force, more pressure can be generated, and because of that pressure, you can easily cut the vegetables and fruits. So that's why all sharp objects will be having lesser surface area at the tip of their sharpness. So this is all there in this particular video. Like this, if you want to learn more physics, chemistry and mathematics starting from 8th standard till 12th standard, then you have to subscribe to my channel. Please do subscribe to my channel and stay tuned with my channel. Thank you.